Hey everybody, welcome to Let's Play with Mrs. Casil here. I'm going to just go through a couple of these FTC Sims so that for those viewers still working on them, you can use this as a guide to work through it yourself too. Sometimes it helps to have somebody, talking a little bit more than the tutorial guide. Plus, I've done a couple of these before, but I don't remember them, so it'll be like I'm working through it for the first time. To clarify a few things, first, it is very late at night. You can see I have an amazing backlit situation here, so I really am here, but the lighting's terrible. This is, however, the most comfortable seat on the couch. For background entertainment, we've got the washing machine running, which will sing a song when it's done, so prepare yourselves. And the West Wing is also playing on the TV. So, welcome to a window into the life of how does Mrs. Casil do school. So, this is the very first one. I'm trying to get my robot to hit the flag here. So I've got this like startup code that's here, right? So they give you this little scaffold to get started. When you write your own code, you have to do all this yourself. You have to bring in several different packages of data that have been coded that are basically bits of firmware. So you've got these classes that you bring in that include data so that when you start typing stuff into your code, it means something when it's compiled, when it's put together into electrical actions. Which first, pause, isn't it cool that we can do that? Crazy. I'm going to work through the blocks mode, and then at the end I'll flip over to the Onbot Java so you can see what the Java part of this looks like. So basically what's here are three things, two of which we need in this program, and one of which is just there for funsies, I guess. So the first part is this op mode. So this is basically the overarching program. Everything that goes in here is the program begins with the necessary components that are going to translate your blocks into correct. Oh, here, washing machine singing a song because it's all done. So it's going to translate the code into the right actions. So that's what's implied here. Then there's some initialization blocks here. Sometimes before you start a program, it helps to set up a few things in advance, right? This is kind of like when you're cooking something, it helps to get out all your ingredients before you get started. So you're not mixing something or heating something and then go, shoot, I need to go to a cupboard and find a jar of something that's going to get mixed in my recipe. So there are sometimes initialization blocks, things that we want to set up to execute before the main actions of our program will run. So the next thing here is the main part of our program. So it says put the run blocks here. These blue things, by the way, are comments. This is essentially information that's here. These things don't do anything. They're just hints and helps for us as we build our code. And then this is the part we don't need in this particular program. There's a loop. So they've put in this green loop. You can even see it matches this green loop over here. See, you can like click stuff and see what's going on there. Oh, cool. There's some text there. Logic. What's under miscellaneous? Oh, yeah. See, enter your comment. That's what those blue things are. That's what's under miscellaneous there. So anyway, so this loop is if we were going to have a single action or a series of actions that was going to repeat. Like, let's say we were going to drive in a square or something. This would be super useful for that, but we're not doing that this time. So what I want to do is get my robot to drive forward. Now, here's the thing. I've got two motors on my robot, and they're sticking out for wheels. If I just tell both motors to drive forward, they're going to rotate clockwise, which means one wheel is going to drive forward and the other wheel is going to rotate clockwise, which will make it go backwards because it's pointing in the it's not pointing in the same direction as the wheel on the other side, the motor on the other side of the robot. So that's the first thing that I'm going to do. I'll show you what happens if I don't add that initialization. So these are DC motors. These are direct current motors. These are the big main drive motors that go on your robot. A servo is a single motor, and it's usually much smaller. We use it to operate arms or winches or slides or lift things or twist something. So I'm going to choose the DC motors. Those are my drive motors. And did you see when I clicked on that, there's one that says dual? I'm going to choose that because I'm lazy. I'd like to I'm driving here, right? I want both my driving motors to move the same. Can you imagine how hard it'd be to control your car if you had two gas pedals, one for the right side of your car and one for the left side of your car? Silly, right? So I'm going to go ahead and just take one of these blocks in here, and I'm going to put this right in here where it says put run blocks here. Okay, that's what I'm going to put there. This says set the motor power to 1, and then it would go on and do everything that's in the program. Move my face. Just realized I was here. So when I run this, this is what I'm talking about. One tire is spinning forward, the other one is spinning backwards, so we go in a circle. So here's where that idea of, oh, I'm just going to click save, because I can do that all the time, and that way I won't get sad when I realize I made a mistake or accidentally refresh my page. So I want to just like permanently make it easy. So like if this was a huge program, I can change this, right? I could go in and say that this is -1, right? What happens if I do that? If the left goes the other way, oh, cool, my robot drives forward. Ooh, too far. It's still trying to drive. In real life, it'd be grinding against that wall there, so that's not very helpful. But imagine if I had a really complex maze that every single time I'd have to go and change that. It's pretty annoying, right? So instead, I'm going to go up here. I think it's under the DC motors. Yeah, over here. See where it says set motor direction? I'm going to grab one of these blocks and put it up here in my initialization. Basically saying, hey, before you start driving, please do this for everything that follows. And I'm going to say that the motor direction is reversed for the other one. So check out what happens now. So now my code says this. Hey, we're going to turn on motors, flip what the left motor's doing, turn on the power, go. Yes. Okay. But now I need to get it to stop on there. So basically, this turns the motors on but leaves them on forever. And this loop that's here is saying keep repeating this while the op mode is active. So I'd have to add a block to make everything stop in here. So instead, I want to figure out something that's going to exactly measure how far this is going to go. There's more things we can do with this later when we get to sensors, but I think it's under utilities. No, it's under linear op mode, I think. So these are like your main, most common functions, right? This one right here, sleep. Lots of different coding systems have a sleep function. So I'm going to put this down here. I'm going to put it right after my motor, because you think about the order that I'm doing things. I'm saying, hey, flip the left motor. Okay, we did that. Now for the rest of the program, I want you to drive forward, and you're going to drive forward while you're waiting this long. This is like a wait block. I've turned on the motors, and now it's measured in 1,000 milliseconds. So that's 1 second. So let's see how far it goes. 1/1000. Oh, it's still going. No good. So now I gotta think, why didn't that work right there? I told the simulator sleep for 1,000 milliseconds. What happens if I do 50? Oh, cool. Okay, guys, I made a mistake. Isn't this excellent? So this doesn't make sense right here, right? Something's not working. As I'm going through and doing this, it's not actually making my simulator sleep. It's not making things wait. So instead, I gotta think, where does this go? So now I think I should put, oh, and this is a nice little mechanical thing. I want to move that sleep block. But notice how when I pick it up, it grabs everything beneath it. So I'm going to press the control key on my keyboard, and now look what happens. It pulls out just my one. So I'm pressing and holding control. Do you like how I have my arm up? Like you can see which keyboard key I'm pressing? But it lets me pull one right there. So I'm going to put that in my loop instead. Let's just see what happens. So now let me think through what this is saying. This is saying flip left, turn on the motors, and then repeat while the simulator is active. I'm not sure that's what I want. Let's check it and see what happens. Yeah, it didn't work. It's still driving literally forever. Call the simulator to sleep for 50 milliseconds. So maybe, oops, I'm going to do my control again. Maybe that goes at the end. Let's try it. Nope, not there. What if it's first? So all I'm doing right now is playing around the order that I've got things in, and you can tell that nothing I'm doing is making a difference. So this might not be the thing that I actually want to do. So let's think about things here. Run the up mode, actuators. I don't think I want to do something like this, because that seems like really annoying to have to do that to make them stop. So, telemetry, none of these things make a lot of sense to me. I'm like pretty sure I'm doing the right thing, but I don't have it in the right place. So, and these drop boxes don't do anything else. 50, let me put it back on 1,000. Oh, yeah, okay. Control, click it. I totally feel like this is where it's supposed to go. But as you, oh my goodness. As you saw, it sure didn't do anything. So, turn on. Yeah, okay, so let's think about what's happening. Repeat everything that's in here. Maybe this all needs to be inside the loop instead. So let's try that. I'm going to do control and move this inside the loop. And then I'm going to put, oh, nope, no. And I'm going to put my sleep block in here. Well, that definitely didn't work either. So, but how interesting, you got the same thing happening. So, repeat while, I don't have choices here, so that's interesting. Until, see, yeah, now I feel like I'm messing around with stuff I don't understand, which whenever you're doing that is probably a good indicator. That's what happens with that. No? Okay, see, so I'm stuck. So I'm going to go back to the guide. And I don't want to watch the whole thing. Super buggy on my computer, at least, where the, like, I can't click the controls down here, even though it seems like it should. So I'm going to go ahead and see what's over. So yeah, he already flipped the direction. But he doesn't have anything for the, oh, that's what's happening, you guys. So I haven't told the motors to stop anywhere, right? I figured out that I need to do some timing. So here, I'm going to press the Z button because, or Control Z, because that does do undo. All right, what I was thinking in the first place, but duh, look at this. I'm telling my robot, I'll put it back at 1,000 where it started. I haven't told the robot to stop. So I need to go back and get another one of those dual blocks. I'm going to drop it in here after my wait block and say, would you please turn the motors to 0? And now, oh, I got this. Okay, but that wasn't far enough. So I am going to trial and error, and I actually know the answer. But I'm going to go ahead and put 1,500 in there. Yay, I did it. Okay, so before I click away, I'm going to click save. And I want to walk through what my code does. So I flipped the left motor so that it would obey my commands. Then I turned on the motors, figured out how long I needed my robot to do that driving, and then the thing I was forgetting, I told the robot to stop. And then I didn't need to use my loop for this because this was a single action right here. So my loop has nothing in it. So there we go. That's how I did my first code here. I'm going to flip over to the Onbot Java just so you can see what it looks like. So in here, you'll see a lot of similarities. Here's this overarching, linear op mode that they've brought in on the other one with that big purple block that goes all around it, right? So it's defining my variables here, or it's bringing in these classes that we're going to use here. And then I'm defining what my variables are so that whenever I use these words, the right things happen in my code. And then here's where I put my initialization block, right? So when I put in that one that flipped the left motor, here's what the code looked like for that. Motor left, set direction, DC motor dot direction dot reverse. None of that should make any sense, like be something that you know. You would have to look that up and learn that to be able to use that. So you'd have a book, you'd have a guide, you'd look it up online. So if you look at this and go, this doesn't mean anything to me, of course not. This is something somebody has written, and it's like when you're putting together, like when you've been given a writing assignment to write a poem or something, and your teacher has a specific list of vocabulary words, and you have to figure out how to use them in order to make your poem work, to get your grade. You got to look up what the words mean. You got to look at the definitions to figure out how to fit them in the right place. That's basically what's happening here. So one thing that you might need at some point, if you click on your little 3 bars over here, you'll see something that says documentation. Oh, no, I don't want to leave the site, but I will open a new tab. So in the documentation, this is basically the book that goes along with this FTC SIM for the blocks. And you'll see up here, they put the Java equivalent also. So this helps you, this is like the dictionary to sort of talk about what your things are. Now, there's different kinds, like here's the sleep that's a different color than what we had before. So some of them are a little bit different in terms of how they look in here, but for the most part, this is a little sort of hint that might help you. Okay? Anyway, so then it says here, see the comments are these double slashes with the grayed out text. So put my run blocks here. So I set my motor to 1, both of them, because it's already flipped up here. And then slept for 1,500 milliseconds, and then turn the motor off, and then my loop is empty. So that's what my code looks like. Sweet. I'm going to go on and do the next one. Okay, so for this one, I'm driving backwards now. So the YouTube clip gives me a little peek at the answer, right? So, oh yeah, and they used a different sleep function than I did too. So let me find that one. Either that or it's just changed colors. Because I'm pretty sure, yeah, I don't see a legend. Yeah, there's not like a red one in there. So the sleep one I showed you in linear optima that's purple, it looks red in there, so they must have changed the colors at some point. So I'm not sure why, but you know, that's what it is. So anyway, here we go. So now my robot's going backwards. I don't think this is that hard, right? Because this seems like it's really the same thing. So I got to think about what I know from the first one. I'm going to go ahead and first flip my motor direction, but this time I'm going to flip the right motor because then it will go backwards. And I know the left motor is already essentially going backwards. So I can essentially write the same code that I had before. Let me close these crazy menus so it's not as crazy. Okay, I'm going to now turn on my motors. I know that I need to make it sleep. I actually already know how far it is too, which is awesome. So I'm going to have 1500. And the mistake I made the first time, I need to turn it off afterwards to have it stop there. I guess I am just assuming it's the same distance, but you know, whatever. So let's try it and see what happens. Success on the first try. But I'm going to change what I did here. Let's say instead, I'm just going to delete the stuff I put in. Okay, so let's say instead I set it up like I did last time. So, go ahead and reset over here. So now I mean, there's more than one way to solve this thing, right? That was me driving backwards. Let's say I want to turn around and drive forward. I know how to turn, right? Because I did it on the other one. So let's say I want to make my robot turn around. So that's what I'm going to do first. So I'm going to have my robot turn around. And I don't know how long, actually. So I'm going to need to try, oopsie. I'm going to need to try that out. So I'm going to start with like 500. Let's see what happens here. So I set this up just like my last bit of code. And now I'm going to have my robot turn because I know now they're going opposite directions for 500 seconds. Never told it to stop. That's why this is complicated. Okay, so let me put another one of those dual blocks in there. And now, ahead and run this now. Oh, cool. All right, my robot turned. So, but not far enough. So I'm just going to go in increments of 500 until I get, like a little bit better. Oh, that's too far. 750? Oh, it helps if I type the right buttons on my keyboard. I'm having a great time, guys. I love this kind of stuff. I think it's super interesting. What, 800? All right, there we go. Oh, it's like not quite. So, oh, my kids are crying upstairs. Mr. Casella's on it. It's so late. They're having so much trouble. Ooh, really? That was too far? 25? This is some of the part about coding. Okay, that's pretty good. That's not like entirely straight, so the perfectionists in the group, you might end up being obsessive about this and be like, cool, cool. No, I'm going to get it just right, but okay, like that's pretty good. Okay, I'm going to try to remember that number now that I know that that's pretty darn close. It still looks a little crooked, but it's not the worst. So now my robot turns, it stops right there, but I don't need it to stop anymore, right? Now I could just have it drive straight forward after that turn. And then I need to repeat what I did in my last program, which is tell it to drive forward for 1,500 milliseconds and then stop. So set these to 0. Okay, so now my code says, hey, flip that left motor so it's turning the same way as the right motor. Okay, now main program, turn for 0.82 seconds, then drive forward, and then drive forward for 1,500 milliseconds, and then stop. I don't know how real the physics engine is in here, so let's give it a try. Because it may be that there's some drift or some lag. Turning, driving forward, not quite straight, but hey, we made it. So this was another solution, but look how much more complicated it was. And there was a lot more room for error, right? I had to really think about what I was doing. And this was tedious. So when you're the coder, you can decide what's going to happen and what's important to you. Like, let's say you're driving your robot here because you need to lift something. Well, then it's not very helpful to get there backwards, right? You would need to turn around and get there forwards. Or let's say that you need to line up with something you're going to pick up or interact with. So being slightly crooked doesn't work. So you know you'd need to be more precise here. But use your big brain. You can do it. Okay, I'm going to show you what the Onbot Java looks like over here. So you'll see that this code is actually a lot shorter than the block code is because those dual motors end up having multiple lines to them, whereas here they're just like grouped together in 2 lines because they're essentially each separate. They're just auto plugged in. So the same thing's happening here. I'm reversing one of the motors so that it turns the same way forward. Then I tell my robot to turn. So one's going backwards, one's going forwards for 0.82 seconds. And then both of them drive forward for 1.5 seconds. And then they stop. So that is the end of the thing. I gotta run it again. Run Java. Alright, and click save. And alright, the third one. Ooh, this one looks super long. And we're going to go around a U. So you can see that we've got the same sort of thing going on here. We're going to set up our motor to make sure it's going the right way. Then we're going to have these different turns. And I'm just like, even not watching the video, just looking at the screenshot, I see some little teasers here that they're not going at full speed. In my after-school competitive club, one of the biggest challenges is you got to reach back to the back of your head and turn man mode off. Everybody wants to drive their robot at 100% power. You guys have done that for challenges in here too. And sometimes it's not helpful. Sometimes you get too much friction. You don't have enough torque, so it actually slows you down. It pops a gear out of alignment, or it twists something so that then your robot's under tension. So they're doing some of this driving at different speeds. So I think that's probably a smart idea. So we'll see what happens here. Okay. Ooh, I got this little U I got to go around. It looks so tight. Can I zoom in on this? Oh, I can. Okay, if I use my scroll bar. Okay, I have not that far to go forward, and then I need to turn across. And because this angle is here, I can't just drive forward like a square. I'm going to run into this. So if it were me, I would honestly work on how to do the curve. And it's not a perfect circle. I'm back a little bit, so I'm going to need to drive forward for a little bit, do a curve, and then drive forward. That's why we were seeing different numbers there. So I've got a big motion that's curved and two motions that are straight. So a couple things I'm going to set up every time. So first, my motor direction, I think that's super easy to just flip left to reverse. Next, I'm going to kind of set up a few things. And can I duplicate this? I know somebody showed me how. Can I copy and paste that? No, I can't. What happens there? Oh, it copies a lot. Okay. Well, that's not quite what I meant. I just wanted to copy this. Oh, I can duplicate if I click on the right part. Duplicate. Oh, I can just click to add a comment also. Okay, so I'm going to add a comment here. So this is first my drive forward. This is just going to help me kind of, and then if I do add comment, does it, oh, that's cool. Okay, but I don't like that. I want to see the comments like this. So I'm going to go ahead and duplicate. And then, so after I do a drive forward, then I'm going to need to do the curve. And then I'm going to need to, do the drive to flag. It's going to be a drive forward again. So it looks the other direction in my map, but really my robot's going to be facing that way, so it's another drive forward. So that helps. I'm going to kind of just be duplicating what's up here. Okay, I know how to do a drive forward. I'm going to turn on my motors for some amount of time. And then if that was the end, I would want to stop. But instead, next I'm going to do the curve. So for the next one, for doing the curve, I'm going to be driving for some amount of time. And then I'm going to be, and then I'm going to go to the drive forward part. So it looks the same too. I'm going to grab the power here. And then I'm also going to come to a stop. I suppose I could be clicking on those and duplicating them also instead of dragging them. But I hope it kind of helps to see which menu I'm getting them from over and over again. Okay, so now I need to adjust these because right now what I just put in says turn the motors on for 1 second, turn the motors on. Like this is not helpful. So 1 second is obviously going to be too far and too fast. So I'm going to try like half speed for a minute. And then I'm going to actually like set these other speeds to 0 for just a second so I can just kind of see how that first movement runs. So that's, oh, wow. Okay, so 1 second was way too far. I like the speed, though. That was really nice and controlled. So let's try, like, 0.75 seconds. Okay, I bumped into the wall again, so that's not quite going to help me. So, let's do 600. I'm kind of nervous, actually, about it being that far, so I think I'd like to start the curve even earlier. Okay, I like that. That's awesome right there. Okay, so that feels good. So now I want to do the curve. So for this one, my outer wheel is going to have to go farther. So it's going to need to be turning faster than my inner wheel. So let's just start with like that and see what happens. So I like my first move. Oh, okay. Well, I ran into the wall. So that was not enough curve. So let's try making it curve harder. Ooh, still not enough. I'm gonna like, oh, sorry. Let's go like this. Alright, so my left wheel's turning a lot. Alright, and it's good to know 1 second isn't enough. Let's go 2 seconds. I'm getting closer. I made it a lot nicer around. Oh gosh. Okay, that's really interesting. So I did make it. So I'm going to get to the flag this way. It's not very elegant. Okay, so I almost feel like it's too sharp of a curve now. What if this is like this? I still run into the wall. Yeah, I want to be a little shallower with my, oh yeah, that's no good. So I'm actually going to go back here and try moving my, my robot back a little bit. See if starting, did I actually reset it in between? Yeah, what if this is 0? I start curving right away. Oh my gosh. If I get the right curve, I think I can make it all the way around. Let's try it. I totally am running into the wall and stuff, so. But I kind of like this as a solution, you guys. Okay. I want to turn a little harder, though, so let's try 6. Ooh, 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 don't bump, don't bump. Okay, it's like, oh yeah, I made it. Okay, so I just undermined the planning that I did, right? And just focused on this curve and achieved this. You could tell if I had to do this reliably, it would not work very well, right? So even though this is, you know, what I was doing before, I'm going to go back and make this a little more elegant here, okay? So I'm going to go back to the having it drive forward. And then I like the curve, honestly. It's really not bad. I'm going to drive forward, curve, still bumping into the wall. But I think I'm actually on a pretty good path there. So I'm going to drive forward, just like nudging the wall. Do you see that little bump right there? And I still don't make it all the way around. Let's try moving back a little bit. So my drive forward isn't quite as far. Oh, I need my turn to be a little bit harder. So, alright. So my left motor's driving a little harder. You guys, that was so nice. But I do think now that I've got everything balanced a little more. Oh my gosh, I feel so good about myself. I didn't even have to do the drive forward at the end. So I'm curious. What if I do this one? Drives. Oh my gosh, that's much more elegant. But honestly, it went too far. Not yet. I know it got there, but I kind of want to like do the turn clean. You know, I want to earn it. All right, that's pretty nice. But I want to go with my original, what I was intending. Drive forward, do the turn, stop, and drive forward. Okay. So wow, that's fascinating that 2,500 milliseconds is too much, and 2,000 is not enough. Okay. And maybe the flag is just too close, really. So now if I said drive forward for a teeny amount, 100 milliseconds, 0.1 of a second, let's see what we got. This goes, and oh, I forgot that this was like at 100% power. Let's go. Oh, wait. And same mistake I made the first time. I need to add a stop at the end, right? Okay, there we go. I want this a little more. That is more what I was imagining would happen. So that is pretty good right there. I feel good about that. Okay. So looking through my code, I divided it up in 3 parts: driving forward, going around the curve, and then driving forward again and stopping. I had to remember that part. So that was that was a lot of work to do those things like that. I did achieve it by just doing the curve and getting the curve right, but I can tell that wouldn't necessarily work if it was like a taller U or something like that. I'd need the drive, so I'm kind of glad I practiced it that way. Again, I'm a little cattywampus, so if I needed to be like straight on, I'd need to add some more code to get that to work, but I feel really good about that. That's really good. So there you go, everybody. There in 35 minutes with lots of mistakes, but with not too much. That was my Let's Play for doing the FTC intro right there. So I just did all 3 lessons in there, and it wasn't that hard. I had to not give up, and I had to, like think about what I wanted the robot to do before I tried things. So hopefully this will help those of you still working on it. Good luck, everybody. Thanks for learning with me.